Welcome to today's Oracle Machine Learning Office Hours feature highlight. So our topic today is creating and using Conda environments with third-party Python and R packages on Autonomous Database. From our speakers, Hannah Nguyen and Sherry LaMonica. I'm your host, Mark Hornick. You may recall that we announced the availability of custom Conda environments with third-party Python and R packages last December. Hannah will give us an introduction to this feature, and Sherry will demonstrate the creation and use of Conda environments with OML Notebooks, OML4Py, and OML4R. And in case you missed it, I've included the link to the announcement in the OML blog here. As always, if you have questions, please post them in the Q&A, and we'll address them during the session or at the end. So before we get started, let's take a quick poll. What is your level of familiarity with Conda environments? Have you used them in data science projects before? Are you familiar with Conda environments but have never used them? Or are you just interested to find out more about what this feature is all about? Okay, we've got almost half of folks have used them in data science projects before. 21% are familiar with what it is, but have never used it. And about a third are interested to find out what this feature is all about. That's a good starting point. So thank you for your responses. And with that, I'll turn it over to Hannah and Sherry.
Thank you, Mark. So for today, our goals are to overview Conda environments, discuss the benefits of using Conda environments in Oracle Machine Learning. Then we will review Conda environment lifecycle management, followed by the typical workflow for environment creation and usage. And finally, we'll see a demo of those two workflows. At the end of the session, we'll open it up to question and answer. So machine learning is driven by freely available third-party and open source software. On this slide, we've included some examples of some very popular Python and R libraries. Third-party open source software is even more prevalent than ever, with enterprises increasingly adopting it, and this is both in consumption and production of open source. So in practice, you rarely use one or two third-party libraries in a project. You'll use many, and a typical machine learning project involves sometimes tens or hundreds of packages. So what you need is more than just a package manager. You need to be able to package these libraries in distinct environments, and this is what Conda was built for. Conda is both a package and environment manager, and it is the ideal tool to isolate dependencies in your machine learning projects. On this slide, we have an example of how one could create separate environments for two different projects. Today, we're excited to introduce this new feature in Oracle Machine Learning. This is driven by the partnership between OCI and Anaconda. Oracle Machine Learning Notebooks now supports Conda environments with third-party Python and R packages on Autonomous Database, which addresses a variety of use cases and modeling needs. Oracle customers now have unlimited use of Anaconda technology anywhere on OCI, and this includes the Conda package and environment manager, as well as the use of the Anaconda repository of packages without having to purchase a separate license from Anaconda. Conda is an open source package management system and environment management system, which allows you to install, run, and update packages and their dependencies within a Conda environment. And with Oracle Machine Learning Notebooks, we provide a Conda interpreter to install these third-party Python and R libraries in a Conda environment for use within notebook sessions and also in OML4R or OML4Py embedded execution invocations. There are many benefits of using Conda environments in Oracle Machine Learning Notebooks. First, you can create and manage custom Conda environments in your OML notebook session. Conda allows you to install third-party Python and R libraries from Conda channels and also use the third-party library code directly in your notebook session. So how does Conda solve for dependencies? It uses a satisfiability solver to verify that all of the requirements of all packages installed in a certain environment are met. This check helps prevent the creation of broken environments. Our next benefit is that in embedded execution, you can run UDFs with third-party package functionality. Engines are spawned and managed by the database environment, and users are able to leverage data parallelism and task parallelism. Finally, the Conda environments that are created persist after you deactivate a notebook session. They're saved in object storage, so all database users are able to download them into their notebook sessions for future use. This enables collaboration, scaling, and it can be used for various projects, teams, and use cases. Now we're going to launch our second poll.
Thanks, Hannah. So which aspects of this feature for Conda environments do you find most compelling? And select all that apply. Is it using third-party packages directly in your OML notebooks? Is it using third-party packages with embedded execution? Is doing it from R or Python, or using the SQL or REST interfaces most of interest to you? Okay, so we're seeing about 2/3 highlighting using third-party packages in OML notebooks, about over 40% using third-party packages in embedded execution. Python is coming in at 61%, R at 25%, and using SQL and REST interfaces ties Python at 61% as well. That's great feedback. Thank you. Back to you, Hannah.
Thanks, Mark. Our next section covers Conda environment lifecycle management. On the slide, we've included the Conda interpreter commands that are available for use in OML notebooks. On the right side of the table, we have marked the commands that are admin only and ADB specific. Admin only commands include commands that are related to managing environments, such as creating it, installing packages, uninstalling packages, and ADB specific commands are commands that we have created that allow our users to persist environments to object storage to download for later use. I just wanted to highlight a few of our commands that we'll be going over later in the demo, which is, the first one is create. This create command creates a Conda environment. Our next command that we will highlight is activate, and this activates a user-created local environment. Finally, we have download on this row right here. This is a command that the user will use to download the environment for use. Next, we have some typical workflows for creating and using Conda environments. This slide here shows the typical workflow for Conda environment creation, which is performed by the admin. First, the admin will create and activate a Conda environment. Then they will locate and install packages from various Conda channels, and then they will verify packages, that their packages are inside the environment, and then they'll upload them to object storage and verify that upload. This next slide shows how the typical workflow for using Conda environments, which is the user workflow. First, the user will download and activate the environment, and then they will list all available packages and import the libraries that are needed for the project. And then after that, they'll develop the code. Today, Sherry is going to demonstrate both of these workflows in the live demo. So now she'll go over an example of the typical admin and user workflow using two OML template notebook examples. I'm going to pass it to you, Sherry.
Okay, thank you, Hannah. Okay, so here you are looking at OML notebooks, and I have two notebooks to show you. The first is the notebook that the admin would use to create the Conda environments. And the second one is the usage where the user would download the Conda environment and then actually use the third-party code. So let's get started. So at the beginning of this notebook, we have all of the different supported Conda commands and how to use them. We have looking up help, how to create Conda environments, activate them, install additional packages, remove packages. You can look at your saved environments, and then finally upload to object storage for all of the users in your database. So here we have a Conda paragraph. And when you have a Conda paragraph, you're already in the Conda context. So you don't actually need to type Conda help. You can just type help, and it will show you all of the available commands and what they do. If you want additional information on a specific command, you can put the command with the help flag to see all of the options for that specific command. And this just goes through all of these options. What I wanted to bring, you can search for packages. So if you want to see if any of the Conda channels that are available to you contain a certain package, here we're searching on scikit-learn. You can search on scikit-learn and then look through all of the local channels that you have and tell you the package, the version that's available, and which channel it's part of. And in this case, it's part of the free channel. And this accepts wildcards. You can search for packages that have a scikit in the name, and you can search for a specific version of a package. So here we're looking for NumPy equal to 1.12 or greater than 1.12, and then you can search for a package on a specific channel using this syntax here. So I want to look for NumPy on Conda Forge, and then it will tell you which is an external channel. So we have, you can search external channels as well. Anyway, and so the enhanced Conda commands, Hannah mentioned these are specific to Oracle, and they support persisting these Conda environments to object storage after they're created so that the user can download and use them. And when you persist the environment to object storage, it's managed by Autonomous Database and available to every user in your database. So let's go down to the minimum steps that the admin would need to do to create a Conda environment and upload it to object storage. So this is creating a Python Conda environment. And it's important to note that your Python packages will be in a single Conda environment, and your R packages will be in another. So you'll create Python Conda environments and R Conda environments. And here I'm creating an environment called mypyenv, and I want it to look in Conda Forge using Python 3.10 because that's what OML4Py supports. And I'm going to install TensorFlow and Seaborn, those libraries. The override channels and strict channel priority, this speeds up the Conda environment creation because it forces Conda to only look in Conda Forge for these packages. And here I'm using the create function. And when I do that, it tells you when it's done, and then it shows you every fourth-party dependency and third-party dependency that you have in the Conda environment. And you can scroll down and look through the list, and TensorFlow and Seaborn are in there. And then for R, I'm creating an environment called my renv with compatibility for R405, which is what we support in OML4R and OML Notebooks today. And again, I'm installing Forecast and ggplot2 from Conda Forge. And so that creates the myrenv Conda environment. Once that's done, I can upload them as admin to object storage. And this is what that looks like. So first I'll save the Python environment to object storage. I'm using the upload command. I'm overriding any environment that already exists in object storage with this name, mypyenv. I'm giving it an optional description and another tag, the user. That these are optional, but the application tag is actually necessary because that will let us know which embedded interface we'll be using if we want to use these in embedded mode. So either OML4Py or OML4R. And then for the R environment, I'm uploading that again with a description, a user tag, and an application tag, which is required OML4R. So now that these environments are saved to object storage, they're available for the user to download, and they will be there until they'll stay there until the admin deletes them or overwrites them. And that would be very simple, just delete and then the environment name if you wanted to do that. So that's the admin workflow. And next, I will show you what the user would do once the Conda environment is created and persisted to object storage. So we will load our user notebook. there's a lot of information in here, and I'm going to go over the most important points. So I have two examples here. For OML4Py, I'm going to load that Python environment, myPyenv, and I'm going to build a model using Keras that predicts iris flower species when given flower measurements. And the iris data set is everybody's familiar with it. It's a popular test data set that's shipped with scikit-learn. So if we go down here, we're also using, I mentioned in here, we're using pandas and NumPy and scikit-learn. Those are actually shipped with Autonomous Database. Those don't need to be explicitly created, installed into a Conda environment. So first thing that I would do, and this needs to be the first paragraph in your notebook, is to download and activate the Conda environment. And once I do that, I can use the list command to view all of the packages that are contained in that environment. And now I'm free to, in a Python paragraph, import the packages that are in that environment, just as you would outside of OML notebooks. And so I'm importing Keras and Seaborn and Pandas and NumPy. And then I'm loading the iris dataset. I'm loading it from Seaborn, actually, not scikit-learn, and looking at the first few rows of the dataset. And then I'm creating a pair plot to look at the pairwise relationships in the dataset using Seaborn. Splitting the data into test and train sets, and then building the model. And I show you these commands just to show you that you can use these packages just as you would in a standard Python session. But so I'm scoring the test data, getting the accuracy of the predicted values. And now what I'm going to do is use our embedded APIs, our embedded Python APIs. We support them from Python, SQL, and REST. And so the first thing that I do is create this proxy object, myDF, and create a database table DF so that I can run the embedded APIs using this proxy object. I show the first few rows of that. So here now I'm creating this UDF, and this UDF contains all of the same commands that I just showed you in the Python paragraphs. The reason that I'm creating the UDF is that I'm going to save this to the script repository, the Python script repository, because then I can call this UDF as a script from the SQL and REST APIs, or Python as well. So just as a quick test check, I run the UDF in Python, and then I run the UDF using the Python API for embedded execution. That's OML table apply. I'm passing my, my proxy object, the function name, and I'm setting the graphics flag to true because the UDF returns both data and an image. Now I create a string representation of the UDF and save it to the script repository using OML script create. I'm saving it to the script repository as a script with the same name as the function, build mod, and I'm overriding any script in the script repository with that same name if it exists. Now to run this from the SQL API for embedded execution, I'm going to use the PyQ table about function. And in OML notebooks, I first need to get a token. I'm exchanging my username and password for a token to run both the SQL and REST APIs. And I didn't show those steps here, but I've already acquired my token, and now I can use PyQ table eval. I can input the table name and my parameters. I'm setting the graphics flag to true because we're returning data, and the async flag to true because we support both synchronous and asynchronous mode. The script name in the script repository is build mod. The output format is PNG because I'm returning an image. The script owner is null because the script was saved by me, but if it was shared with me by another user, I would put the script owner here. And then the environment name, the Conda environment name is myPyenv, and I get back a job ID right here. And with that job ID, I can use that to poll the job to get the status using the PyQ job status function. when I do this, I'll get either the result location like you see here, or I'll get a message that the job is still running. And then to retrieve the result, I use the PyQJob result procedure with the job ID, and I pass the output format as PNG because I'm returning both the data and, as you can see, the PNG image bytes. Then if I wanted to call this from the REST API, both synchronous and asynchronous modes are supported. And as you can see, I have this curl command, which does not run in OML notebooks. It's here for illustrative purposes. You would want to use a REST client like curl or postman. But if I ran this curl, I would send a post request to the table apply endpoint, specify my script name, build mod, and then I would include the table name, the environment name, and set the graphics flag to true. And then the result would return both data and image. And I can do the same thing in asynchronous mode. I would get a job ID, and I would just need to pull the job ID to get the status. And when the script finishes running, I'd get both the data and image back. I can do all of the same things that I just showed you with Oracle Machine Learning for R. So in this case, I am downloading my R environment and activating it, my RENV. I'm listing the packages in the environment. Now I'm jumping straight to creating my R UDF and saving it to the script repository. You can run these commands outside of the UDF in an R paragraph in OML notebooks, but for the sake of time, I'm jumping straight to the R UDF. I can run the R UDF in R or through the R API for embedded R execution using ORA doeval, passing the function name and setting the graphics flag to true. And I'm getting both data and image back here too. The SQL API for embedded R execution, RQEval2 is the equivalent to doeval. I'm setting the graphics flag to true and the output format to PNG because I'm returning an image. The script name is multi-forecast and the environment name, my RENV, and I get back both the data and the image. And the REST API, we support, again, both synchronous and asynchronous mode. We'll just look at synchronous mode. And you can see that I'm sending a post request to the doeval endpoint specifying my script name in the script repository, multi-forecast, the table name, the environment name, my RENV, and setting the graphics flag to true, and I get my data and image back. Now, just to show you what this would look like in Postman, a different REST client. So the first thing that I need to do, like I mentioned, is get this user token. And I have saved in this environment that I've named Conda Environment, my OML URL, which is called OML server, and my username and password. And what I have done is saved the token to a variable called token. And when I do that, I get my access token back, and that is good for an hour. And I can extend that before it expires if I want to. But now I'm going to use this token for all of my REST requests. And I'm not going to run these. I've already run these. I'm not going to run these again because they take, in the interest of time, we only have a few minutes left. But as you can see, I am sending a post request to the doeval endpoint specifying my script name. And I have all of my input parameters in the request body. So my table name, the environment name, and I'm setting the graphics flag to true. And I get back both the data and image. You can see it a little bit better here. And same with the predicting the iris flower species for OML4Py. I'm sending a post request to the table apply endpoint specifying my script name. And the difference between these two, obviously, is that this is Py scripts for OML4Py, and then I'm pulling the R scripts for OML4R. And that's it. I think we have another poll.
Indeed. So as we've seen this, the demo and had the overview, what do you feel is your likelihood of using Conda environments in OML notebooks? Is it something that you'd plan to use in future projects? You still need more information before you can start using this feature, in which case definitely reach out to us. Or you don't plan to use this functionality, but just wanted to learn about it. And if there are specific third-party libraries that you'll be using, we would be interested in knowing, what some of those would be, and you can add those in the chat itself. So what we're seeing here is about over half plan to use it in future projects, and about a third of you need more information before you can start using it, and only a couple of folks don't plan to use it. We're just here for information purposes. So thank you for responding to that poll. That's great to see.
Okay, and so for more information, here are some resources for you. Our OML webpage, blog, our GitHub repository that has a lot of examples, including some Postman collections, and we should have the Conda notebooks out there soon. You can also get them in the OML template notebook examples. A link to our OML office hours and our live labs and documentation. Okay, so let's open the floor for Q&A.
Well, Sherry, we have one outstanding question here. Can I install, overwrite a specific version of pandas?
So yes, you can. If you had an existing version of pandas, like the one that ships with our OML notebooks, and you created a Conda environment that had a different version, you could use that. But it's important to remember that we're supporting Python 3.10. And that's all that we're supporting. So what I have found is that you need to install a version that is compatible with Python 3.10.
Okay, thank you. Another question, is it possible to install packages that are not available in Conda channels, for example, using pip?
That is a question that actually came up last night in my Slack channels. I am looking into that. I do not think that we have pip in our Python containers, but there may be another way to do that, but it wouldn't necessarily be supported through the Conda environments.
And one question that was touched on in the text response was, is it possible to upload an existing Conda environment from outside of OML notebooks?
Not today. Not today. That's a good enhancement, though. You'd have to recreate that within your notebook session as admin.
It looks like we're all set for questions. So Hannah and Sherry, thank you very much for today's session, the presentation and demo. And we'll look forward to seeing all of you at our next OML office hours. Take care until then.
Okay, thank you, everyone.